In this section, we're going to discuss the different types of lights that your potential customers currently have. Remember that our primary focus is finding companies who want to retrofit their existing lighting systems with LEDs. Thus, it is critical that you understand the light products out there so you can persuasively argue why the customer should switch. With that said, let's begin. We'll briefly go over the major categories of lighting that you'll run into while you're chasing down customers. The most popular is incandescent, which we went over in some detail during the previous section. CFLs are the popular choice for an allegedly greener alternative to incandescents, but as you'll soon see, you might not want to believe the hype. Fluorescent is the standard choice for non-residential environments like offices and retail stores. Halogen is a variation of incandescent that burns both brighter and hotter, thus allowing it to give off a brilliant white light. High-intensity discharge lights are generally for large-scale environments like streets or parking lots. And then finally, we have LEDs and induction lights, which is what we're all waiting for. But let's start with the media darling, CFLs. First of all, how does a CFL work? Well, a CFL is essentially just a fluorescent light that has been miniaturized and given a standard base that allows you to screw it into virtually any lighting fixture. What you hear throughout this training is that the technological advancements that allowed widespread use of a particular light is usually not the light itself. Rather, it's the base and the configuration of that light. For example, LEDs have been around for 70 years, but it's just in the past few decades that LEDs have been configured such that they can be used in common everyday fixtures. With CFLs, it's the same situation. Fluorescents have been around forever, but it was only after they figured out how to screw them into a standard lamp base that they took off as the alternative for incandescents in a residential environment. The CFL works by passing electricity through a tube containing gases. The combination of the electricity and the gas results in a reaction that creates ultraviolet light, which is then transformed into visible light by the phosphorus coating inside the tube. CFLs have an internal ballast and a standard screw base so they can work without any auxiliary equipment like ballasts or starters. CFLs are typically used to replace incandescents and do in fact reduce the energy required for the same amount of light that you would expect from an incandescent bulb. CFLs are also generally bent in a zigzag or corkscrew shape, which saves space, and they contain a small amount of mercury vapor, which is essential to the CFL because it excites the phosphorus coating, resulting in the ultraviolet light. That mercury, though, as we'll discuss in a minute, is a big problem. But let's start with the good side of CFLs and why they're considered the primary alternative to incandescents. The bulbs themselves are more efficient than incandescents, but they still only convert 20% of the energy used into light. While that's double the efficiency of the incandescent bulb, it's better, but not nearly good enough. CFLs have a 2% market penetration and are often hailed by both the media and the government as the right choice for energy efficiency, but as you will learn throughout this presentation, there are many other alternatives, such as LEDs, which are tremendously more effective. Continuing though on the good side of the column, CFLs last 5 to 7 times longer than incandescents, or up to 10,000 hours. This efficiency, while less than what is available for other lights, would still have huge environmental benefits if more people use CFLs to replace their standard bulbs. For example, if each home in California had 5 CFL bulbs instead of incandescents, it would be the equivalent of pulling 414,000 cars off the road. But while these benefits are apparent, there is an ugly secret behind CFLs, and that is the mercury used to create the light. You see, mercury is highly toxic. As long as the mercury stays in the bulb, though, it can't hurt you. Unfortunately, bulbs do break, especially when they're thrown away, and that results in a release of the mercury into an environment which over time can cause very undesirable results. One study, for instance, shows that in Los Angeles County, 40 pounds of mercury per day, that's every single day, is leaking into the ground underneath landfills due to broken CFLs and possibly entering our aquifers and underground water supply. This is a serious health problem that authorities have not yet solved and very few people talk about. Also, as a side story, I can tell you that mercury sometimes has direct results on the people who handle the bulbs themselves. For instance, we know one facility manager who came down with mercury poisoning. He didn't know where he got it, but he was persistently sick and tied to medication to treat the affliction. One day while we were walking with him in the facility, he took us into the old light bulb room, which was essentially a trash can for old bulbs from the building. It was chock full of broken CFLs, defective CFLs, and materials that had spilled out of old lights, and this was the source of his mercury poisoning. Once we pointed it out to him, The building owners clean up the room, and miraculously, the facility manager's disease literally disappeared. Mystery solved. These are stories, though, that most people don't know about, and they continue to believe that CFLs are the way to go. You can tell them the stories we just related to you, but maybe they won't believe it. And if that's the case, ask them if they know what the EPA says about CFL removal. Direct them to the EPA. The EPA is the Environmental Protection Agency. Direct them to the EPA website, which says that if a CFL is broken, the entire area should be cleared out for several hours, and people in hazmat suits are supposed to come in and sweep up the mess and flush the potential toxins from the air. How do you think that would go over in a restaurant that has CFLs? Or a supermarket? The grocery retailer, Whole Foods, banks their entire reputation on green company policies. What kind of press disaster would it be if a CFL hanging over the produce at Whole Foods broke and a bunch of guys in hazmat suits arrived to clean up the mess? CFLs might be your biggest obstacle in convincing building owners they need LEDs because from their perspective, they've already gone green by switching from incandescent to CFL. However, when you hit them with facts like these, it just might help you cement your sale. So to summarize the CFL's positive traits, they are up to 400% more efficient than incandescent bulbs. They last up to 8 times longer. And since they give off less heat than incandescents, they're less of a fire risk and less of a burden on HVAC systems. Here's a chart showing the energy savings from incandescent to CFL with an extra column thrown in for LEDs so you start to understand why, although the government backs CFLs, they simply cannot compete with the products we offer. If you read through these numbers, you'll see that CFLs require just 20 to 30% of the wattage to create the same number of lumens as incandescent bulbs. However, even with that dramatic savings, LEDs can save an additional 50% or more over and above what you get from CFLs. Taking an energy bill from $10,000 to $3,000 is great. Dropping it down to $1,500 is even better. Still, as we discussed, we believe, and hopefully your customers will too, that the disadvantages of CFL bulbs strongly outweigh the benefits. CFLs are much more costly than an incandescent bulb, thus the longer life is offset by the greater cost and probably not really that much of a value. Plus, when you turn the light on and off, which occurs frequently in both a residential and non-residential environment, the lifespan of the bulb is shortened considerably. CFLs don't always fit into the lighting fixture, and their light output on occasion does not match the manufacturer's claims. Plus, the lamps take a few minutes to warm up, and they can be temperamental in extreme temperatures. And finally, let's not forget about the mercury, which is a highly dangerous toxin that does not always stay where it's supposed to be. Now, let's talk about some standard fluorescent tubes. Again, the lights work by passing an electrical current through a gas-filled tube to create ultraviolet light, which is then transformed into visible light through a reaction with the phosphorus coating and the mercury. These bulbs last 10 to 20,000 hours and are thus much more efficient than their incandescent equivalent. Because they produce less heat, there's less burden on your HVAC system, and over the past few decades, fluorescent lights have been developed that have a better color rendering index, which means that the lamps can produce lights that show the surrounding colors of the environment in a much more vibrant manner than before. The color rendering index, or CRI, is something you'll hear about often. Certain light allows color to be set to be seen better than with other lights. The higher the CRI, the more vibrant the colors appear. So a higher CRI is generally perceived as a good thing, at least where color in the environment is important. CRI is less important though with a streetlight, for example, where the utility doesn't really care how green the ivy looks below the light. To mention some other facts about fluorescent tubes, generally speaking, they have a cool appearance, which is measured at about 4,200 degrees Kelvin. Kelvin is a temperature reading, and the brightness of the light is measured by its Kelvin temperature. The lower the Kelvin, the warmer or more yellow the light. The higher the Kelvin, the brighter or whiter the light is going to appear. Fluorescents are generally categorized as T5, T8, or T12. The T stands for tubular. The number is how wide the tube is multiplied by 1/8 of an inch. So for example, a T5 is 5/8 of an inch wide. Fluorescents also use rare earth elements, which is not good because those elements are scarce and subject to shortages, which could cause price spikes occasionally depending on availability. Now, you can get fluorescents in a wide range of colors, but they're not ideal for areas where detailed work is being done due to the manner in which the light is emitted. And they generally don't work with dimmers. They're either on or they're off. From a mechanical perspective, fluorescents need external components called ballasts, which regulate the voltage to the light fixture. Generally, you'll see a triangular or flat cover on top of a fluorescent light fixture. Underneath that cover is the ballast. Ballasts are both electronic and magnetic. The electronic ballast solves some of the flickering you often see with fluorescents. They're more efficient, but also more costly, and some require a starter. Also, the ballast requires additional energy to function. So if you have a 32-watt fluorescent bulb, it's pulling more than 32 watts because the ballast needs a couple watts to survive. That is additional energy savings you'll receive when you switch to LED because LEDs don't require ballasts. Let's talk a little bit about halogen lamps. These are not very popular, so we'll just brush over some very basic points. Halogens are similar to fluorescents in that they pass electricity through a tungsten filament, which creates light when it reacts to the halogen gas inside the tube. The halogen lamp burns much hotter and brighter than other lights, which is why you get a brilliant white color from a halogen lamp. Halogen lamps are more efficient than incandescent, but not by much. They have a longer life, they're smaller in size, and they can work with a dimmer. On the negative side, halogens are much more expensive and burn hotter, resulting in both fire hazards and additional loads on your cooling systems. Let's talk a little bit about high-intensity discharge lamps, or HIDs. As we said earlier, HIDs are very small lamps that give off huge amounts of light, which is why they're used in large areas like parking lots, gyms, streetlights, and stadiums. Different types that you'll hear about are high-pressure sodium, metal halide, and mercury vapor lamps, among many others. Most HID lamps require ballasts and starters, just like fluorescent tubes. This slide shows you what some HIDs look like. We have a typical mercury vapor bulb, metal halide bulb, a high-pressure sodium bulb, and a fixture you might see associated with a high-pressure sodium. There are many, many variations, however, and these pictures just give you a small cross-section of what you'll see out there in the real world. You might want to click pause right now and do a Google search for HIDs so you get a wider range of examples. Chances are in a lot of the buildings you'll survey, they'll want to change out their parking lot lights due to the number of hours that parking lights stay on and the energy needs associated with them. And when you quote the parking lot or structure, you'll often see HIDs, so you should be familiar with the different types that are out there. As we discussed before, here's some of the more common uses for HIDs. If a customer wants you to walk outside to count their lights, you should probably expect to come into contact with HIDs. Gymnasiums, large public areas, and roadways are all amenable to HID lamps, and the more familiar you are with them, the better your chances of convincing the customer to switch. One particular type of HID that you'll often see is the high-pressure sodium lamp. This lamp has the highest efficacy of all HIDs, but does require a ballast and also has a brief warm-up time. Moreover, the light emitted by the high-pressure sodium is yellowish in color, and thus the color rendering is very poor. But since parking lots and streets don't require a vibrant color environment, a low CRI doesn't have much of a negative effect. So let's summarize a few facts about HID lamps. High-pressure sodium lamps are extremely efficient but produce a yellowish light with a very low CRI. Metal halide lamps are less efficient than high-pressure sodium but produce a broader range of light and color. And HID lamps in general are efficient, have a longer life, and can produce light over large areas. And that pretty much wraps it up for section 2. Again, I can't emphasize enough that what we've presented to you here is just a small sampling of the types of lights that are commonly used in your customers' buildings. The more time you spend doing counts and quoting deals, the more variations you'll see. Nothing is a substitute for experience and research. So in order for you to become an expert on these lights and increase your chances of securing a sale, you have to do your research and visit as many facilities as you can. The more you know, the better you'll be. And that brings us to the end of section 2.